Let's talk about sensors, the hidden gems in the modern world. The new podcast series from Dr. Block, brought to you by All About Sensors. Season 1, Episode 5. Dr. Block explains how barometric pressure sensors help to make hearables better. Brought to you by All About Sensors. Thank you. Enjoy.
Welcome to the Deep Dive. Today we're looking at some really interesting material you sent over on new ways to interact hands-free. Specifically, we're digging into something called Barton. It uses, believe it or not, barometers inside your ear to sense tongue movements. So, okay, let's unpack this a bit. The mission today, understand how this, seemingly simple tech offers a potentially revolutionary low-power way for hands-free control, and how it gets around some pretty serious limitations of the methods we have now.
Yeah, it's a really important area. I mean, the need for good hands-free interfaces is just growing rapidly across so many situations. Think about, say, a firefighter in a really noisy place needing to communicate silently, or, just you trying to skip a song on a crowded train when your hands are full. We need interaction that's, seamless and doesn't draw attention.
Right. And what really jumped out at me here was the discreteness. Instead of like complex cameras or sensors stuck somewhere weird, this thing just integrates into something loads of us wear anyway, earphones.
Yeah.
How did we even get here from those more cumbersome older approaches?
Well, historically, the solutions for sensing tongue movement, they were often quite intrusive, really. We've seen stuff mounted right on the tongue, which, or these clunky electrodes attached to your jaw, even computer vision methods, but they typically only worked if your tongue was literally sticking out, not exactly practical for everyday life.
Yeah, not ideal. And even the less intrusive stuff like microphone-based systems in the ear, they had their own big problems, didn't they? Interference, battery life.
Exactly. Huge drawbacks. They were really vulnerable to audible sound, like the music playing in your earphones could mess them up. Plus, the audio processing needed, often things like fast Fourier transforms, complex math to analyze the sound. It just consumed a lot of power, drained batteries fast.
Okay, so that sets the stage. With all those challenges, how does Barton, the barometer-based, low-power, and robust tongue movement system, how does it change the game? What's the core idea?
The core principle is actually quite clever. Barton measures tiny changes in air pressure inside your ear canal directly. These little pressure fluctuations. They're caused by your facial muscles moving when your tongue moves. Because, your mouth cavity and ear canal are connected. So even subtle gestures create these pressure signals it can pick up.
Wow. And the power figures are just kind of nuts. A 44 times reduction compared to the mic-based systems. What does that level of energy saving really unlock for always-on hands-free stuff?
Oh, it's huge. It completely changes the possibilities for always-on interaction. It's not just about your battery lasting longer. It's about making the tech genuinely invisible, just part of the background. Barton uses only about 8.4 milliwatts. Tiny, and it achieves that with super low sampling rates. We're talking below 50 hertz, even 20 hertz works fine. And really simple analysis of how pressure changes over time, temporal features.
Makes total sense for always on. Okay, what about that other big problem you mentioned, the audio interference? Can it really just ignore my music or whatever podcast I'm listening to and only pay attention to my tongue?
Pretty much, yeah. And this is where barometers just have a natural edge. See, microphones are built for audible sound, right? 20 hertz to 20 kilohertz. But barometers, they're inherently more sensitive to the ultra-low frequencies where tongue movements happen typically below 6 hertz, like way below audible sound. So that difference just makes Barton naturally resilient to music, speech, whatever. It's a critical step for using it in the real world.
That is a massive leap. Okay, but if it's just feeling pressure, how does it know if I move my tongue left versus right or forward?
Yeah.
And how does it avoid getting confused by, say, just me moving my head?
Good question. If we look at the bigger picture here, it comes down to a really smart design choice. Using two barometers, a pair, one in each ear. Different tongue movements create different patterns, correlations in the pressure signals between the two ears. So moving your tongue left or right tends to create a negative correlation. Moving it forward, usually a positive correlation.
Okay.
And head movements. They tend to generate signals that are much less correlated between the ears. So Barton can tell the difference using those simple temporal features again. It's quite elegant.
So it's the interplay between the two sensors, not just one on its own. That makes sense for getting that kind of precision. And the results, they got 94% accuracy for classifying those main tongue movements. I mean, that sounds pretty solid for real-world use.
It really does. And what's fascinating is how practical it seems. It can integrate into standard earphones, it handles head movements well, and crucially, it keeps that high accuracy even when music is blasting from the earphones. That's a tough test. Plus, it doesn't seem to need tons of training data. They found even just 40 examples per gesture gave decent results. It's about useful control without a massive setup hassle.
So when you boil it all down, what does this mean for you listening? It looks like a clear path towards tech that just disappears. Seamless, discrete control, and incredibly energy-efficient control over your devices, potentially.
Yeah, Barton really feels like a significant step for that always-on, hands-free future, using tech that could just blend right into the wearables you already use.
Which definitely raises an interesting question for you to think about. If this kind of tech was just built into your everyday earphones, how might that actually change how you interact with your devices daily? What sort of new, maybe more intuitive controls could you imagine using, just with subtle little tongue movements, something to mull over?
We're looking into something really quite ingenious, a new way to interact with your tech, happening right inside your own ears. Our mission, basically, is to untack CanalSense. It's this face movement recognition system from researchers over at the University of Tsukuba. And the idea is it turns these, like, tiny movements of your jaw, face, head into hands-free control, just using air pressure, in your ear canals. Okay, so let's unpack that a bit. Imagine your earphones, right? Not just playing music, but actually sensing every little facial twitch, turning these tiny movements, things you probably don't even notice you're doing, into actual commands.
Yeah, and what's really fascinating here, the core idea, is that moving your jaw or your face or even just your head, it actually changes the air pressure inside your ear canal. The real breakthrough wasn't just noticing this happens, but realizing that if you seal the ear with an earphone, your own ear canal basically becomes this super sensitive pressure sensor.
Ah, okay, so it's our own body plus the earphone that's doing the actual work.
Exactly. It happens because your musculoskeletal system, things like the joint where your jaw connects, or the big muscle down the side of your neck, when they move, they subtly change the shape, the volume of your ear canal. And if your ear is sealed up by that earphone, these tiny volume changes, they cause measurable shifts in air pressure. And here's where it gets really clever. These little pressure changes create unique waveforms. Think of them like specific signatures, a distinct pattern for, say, opening your mouth versus moving your face left. It's like a fingerprint for movement.
Wow. Okay, that's pretty specific.
Yeah.
So differentiating between like open mouth and face left, so the system needs to be really precise. How do they actually capture these tiny pressure shifts and turn them into commands? Is it just hardware, or is software doing the heavy lifting?
It's a bit of both, really. The CanalSense system puts tiny, very sensitive barometers, kind of like the altitude sensors in your phone, right into regular canal-type earphones.
Yeah.
And to make sure they get good readings, they really focus on air tightness. They even seal up vent holes, use foam ear tips for a snug fit. These barometers then measure those tiny air pressure changes really accurately.
And then the software kicks in.
Right. Then the system processes those raw barometer numbers. It pulls out those specific waveforms we talked about, and then it uses a machine learning algorithm. Specifically, they use something called a random forest classifier. Basically, it's trained to recognize those unique movement signatures. And the experiments, well, they look pretty promising. Participants got around 87.6% accuracy, recognizing 11 different face movements, and 87.5% for just telling apart 4 different levels of opening your mouth, which, suggests it's fairly reliable.
Okay, that's cool science, but the big question for you listening is, what does this actually mean for your day-to-day tech use?
Well, it means genuine hands-free, eyes-free control. Think about pausing your music just by opening your mouth, or maybe skipping a track with a little jaw slide to the left. Movements that are so subtle you might barely notice them. Or maybe you're cooking and you need to scroll through a recipe. Just tilt your head, slide your jaw. No need to touch the screen. It's really about making technology feel more integrated, more natural.
That does sound incredibly convenient, but there's always the difference between the lab and the real world. What kind of hurdles pop up when you try to take this out into, your everyday life?
That's a really important point. Yeah, the lab results are strong, but real-world stuff could definitely interfere. Like your physical state, if you have a cold or a stuffy nose, that changes ear pressure, right? Or just moving around, walking, talking, that could create noise in the signal. Even environmental pressure changes, like being in an elevator or on a plane. Those could potentially affect the readings too.
And I guess getting that perfect, consistent, airtight seal, especially if you're active, that sounds tricky.
Oh, absolutely. You need a comfortable, snug fit for it to work well, and keeping that perfect fit while you're moving around. That's definitely a challenge. So the next big step isn't just detecting the signals, it's making the system smart enough to deal with all that real-world messiness. Adapting to how your body works, filtering out noise from walking or talking. Maybe it needs quick calibration or AI that learns your specific patterns over time.
So we've seen how this really clever mix of like physics, biology, and machine learning could turn your ear canals into this kind of hidden control interface.
Yeah, and looking bigger picture. Canal Sense gives us this glimpse into a future where maybe our tiniest, most natural movements control our digital world, freeing up our hands, our eyes for other things. Imagine recognizing complex combinations like an open now plus a tilt head.
Right.
You could do so much more. It kind of shifts things from needing active input, like tapping a screen, towards more passive integrated control.
So something for you to think about. What other subtle, everyday body movements could maybe be used to simplify technology? And what kind of weird, unique challenges would that bring into your daily life? Curious minds to another deep dive. Today we're exploring an incredible and honestly pretty intimate frontier in human-computer interaction. It's happening right there inside your own ear. We're diving into an interaction technique so discreet, so seamless, you might just call it telepathic.
Indeed. And we've got some really fascinating sources on this thing called ear rumble. It's basically a method that takes this little-known internal body function and turns it into a powerful, hands-free control for your devices.
Wow. Okay.
Yeah. Imagine controlling your tech without lifting a finger or, even moving your eyes.
Yeah.
So our mission today is really to unpack the surprising science and what users call this magical experience behind ear rumbling.
Okay, let's dig into how this even works then.
Yeah.
What exactly is ear rumbling? For those who might be able to do it, what's going on?
Right. So it's the voluntary contraction of your tensor tympani muscle, tiny muscle, middle ear. Usually its job is to dampen loud noises, protect your hearing. But for some people, contracting it creates this kind of dull, internal rumbling sound. And they can control it on purpose.
It's like a hidden superpower some people have.
That's a fun way to think about it.
Yeah.
And what's really fascinating is how many people might have this superpower. An online survey found, get this, 43.2% of respondents said they could do it.
43%, that's a lot more than I would have guessed.
It is. It's not something people generally talk about.
Right.
Yeah, a big chunk of the population can do it, often without, moving their face or anything obvious externally.
So it makes you wonder, if that many people can do it, could we actually use it for something beyond just a weird party trick?
Precisely. And that's exactly what the researchers looked into. It led them to develop these ingenious Hearables, smart earphones, basically, designed to sense this internal action.
Okay, so how do you sense something happening deep inside the ear like that? It seems really subtle.
It is subtle. These custom-built Hearables are key. When you contract that tensor tympani muscle, it actually moves your eardrum just a tiny bit. And if your ear canal is sealed by the Hearable, like with noise-canceling buds, that tiny eardrum movement creates a detectable change in air pressure inside the ear canal, like a mini pressure pulse you generate yourself.
Got it. So picture this. There's a tiny, super sensitive pressure sensor inside the earphone, kind of like the barometer in a smartwatch, maybe.
Exactly, that kind of tech, yeah. Like a Bosch BME 280 sensor, the sources mentioned. It picks up these minute pressure shifts. Then there's this recognition pipeline, basically smart software.
An algorithm.
Right, an algorithm that learns to tell the difference between, say, a quick single rumble pulse, or maybe a double rumble, or even a longer hold rumble.
And how well did it work?
Pretty impressively, actually.
Yeah.
For single and double rumbles, they achieved 95% accuracy.
95. That's really high for something so internal and kind of fuzzy sounding.
It really is.
Yeah.
Which leads us to the user experience part. This is where it gets really interesting.
Yeah.
Users who tested ear rumble, they described it as magical.
Magical. Wow.
And almost telepathic.
Why? What made it feel like that?
Well, I think it comes down to how incredibly low effort it is. It's hands-free, obviously, but also eyes-free. Think about it. Driving, cooking, typing, your phone rings.
Yeah, usually you fumble for the phone or headset button.
Exactly.
Yeah.
But with this, you just rumble in your ear. Maybe a quick double rumble to accept the call. Done.
Yeah.
The usability studies showed people overwhelmingly preferred it over a physical button click.
Because it didn't interrupt what they were doing?
Precisely. It didn't break their flow. They called it much more practical, even fun.
And the discreteness factor, too. You could interact without anyone around you having any idea.
That's a huge potential benefit, yeah, for private inputs in public.
Yeah.
The research also found most people didn't need to, blink hard or yawn or make weird faces to do it.
Which helps with the discreteness. But, okay, it sounds amazing, but were there downsides, challenges?
Oh, definitely.
Yeah.
It wasn't perfect. While single and double rumbles were great, accuracy-wise, that hold rumble gesture, it was much more problematic. The system often failed to detect it correctly.
Okay. So holding the rumble consistently is tricky.
It seems so. Which raises the question, how do you make these internal interactions even more robust, especially for more complex commands?
Right. And what about speed? Was there any delay? Latency?
Good question. The study showed an initial latency of about 308 milliseconds to start a rumble, which is actually, pretty decent compared to some interaction methods. But maybe not instant enough for everything.
Maybe. And you mentioned needing a sealed ear canal earlier. Does that mean it requires a really tight earbud fit? Could that be uncomfortable for some people long term?
That's a very real consideration. Comfort in getting that perfect airtight seal could definitely be a practical hurdle for widespread adoption.
Okay. So hurdles exist, but the potential seems, huge.
Absolutely. The researchers are thinking way beyond just answering calls. Imagine using complex rumble patterns, like rhythms, for secure authentication.
Like a secret ear knock.
Sort of. Or navigating augmented reality menus with just a subtle internal ear cue. Maybe combining it with other subtle sensors, too. It really opens up this idea of a much richer, more hidden interaction vocabulary.
What an incredible deep dive. Seriously. From this quirky internal sound some people can make to a potential game changer in how we interact with technology. eRumble gives us this glimpse into a future where tech responds not just to our touch or voice, but maybe our most subtle internal cues.
It really does. It allows for this truly intimate, almost invisible kind of control. And it makes you wonder, doesn't it? What other, maybe forgotten biological functions could we potentially repurpose to make interacting with our technology even more seamless, more intuitive?
A fascinating thought to end on. Makes you think about what other hidden controls might be waiting right inside us.
Thanks. That was it for today. Bye.
Thanks for watching. I hope you liked it or learned new things. Please also visit me on X, Instagram, or read my blog articles on WordPress. Bye.